So now let us come to the relational operators. So I just have first given the definition, which goes like: a relational operator is used to compare two operands to decide a relation between them. So this operators is almost like arithmetic operator, but then this is used to compare the two operands. Okay, our operands which we are going to use, it can be any alphabet. For our preference, we are using A and B. Okay, so whatever the result, what we will be getting will be in the form of true or false. Now we also know that during our C programming, when we are using the relational operator, the result what we are getting is in the form of 0 and 1 or 1. Okay, but in case of Python, the relational operator gives us the result as either it can be true or false. If it satisfies the condition, then it will give us true, and if it not satisfies the condition, then it will give us as false. So initially I have made 3 columns over here. Like the first one says the operator, second is the little description, then the third, which we are going to use as example, is the usage. So first we have the lesser than sign. So this returns true if the left operand is greater than the right operand. So in this case, we are considering the A value as 12 and the B value as 3. So as we know that 12 is greater than 3, so the value that will be written, or the result that will be written, is given as true. Secondly, we have the greater than sign, which shows us that returns true if the right operand is greater than the left operand. So now here we have considered the A value as 12 and the B value as 3. Now we know that 12 is not greater than 3. So we will be getting the result as false. Fourth, we have the sign of is equal to is equal to. This returns true if both the operands are equal. If our A will be equal to B, or a B will be equal to A, then this satisfies this condition. So here I have taken the example of 12 equal to 3, which returns false. Then we have the lesser than or equal to. Okay, it returns true if the left operand is greater than or equal to the right operand. When now 12 is greater than or equal to 3, it means that it is satisfying at least one condition, that is that 12 is greater than 3. So we are getting it as true. Next, we have lesser than or equal to, which shows us that it returns true if the left operand is greater than or equal to the right operand. Now when I consider that 12 is lesser than or equal to 3, now we know that 12 is not even lesser to 3 and not even equal to 3. So the answer what we get, or the result what we will be getting, is false. Then we have negation equal to. So this returns true if both the operands are not equal. So what does this negation mean? Negation means basically the complement. Now 12 complement 3. Okay, whatever we are going to get, the complement will be equal to 3. So it will be, now this is not like if you are taking the is equal to sign, so our answer will come false. But here we are using negation, so we are getting the answer as true. Okay, now we are done with relational operators. Now let us just go to the bitwise operators. Okay, so these bitwise operators can be done only between the binary numbers. We have to remember this. Okay, then the evaluation is done between the bits. Okay, so let us go with the definition, which goes like: a bitwise operator performs operation on the operands bit by bit. Okay, now if I consider a number that is A equal to 2 in binary notation, 10. Okay, and B is equal to 3 in binary notation, 1 1 for below usage. Okay, so now these bitwise operators are of many types. Okay, there are like bitwise OR, bitwise AND, bitwise XOR, bitwise complement, left shift, right shift, etc. So now we will be going with the table, which goes like the operators, description, usage. So first we have the operator, which is like the first is, we can see AND sign. Okay, and the description gives us like performs bitwise AND operation to the operand. So when I consider A as 2 and B as 3, A and B equal to 2. So the binary number what we have is 10 or 10 and 11, which will give us 10. Okay. Now next we have the standing slash, that is performs bitwise OR operation. So this sign will be used for the OR operation of the operand. So A or B equal to 3. So 10 or 11 will give us the result of 11. Okay. Then we have the XOR operation. So it is going to perform the XOR operation. So A XOR B will be giving us 1. So 10 XOR B, that is 11, will be giving us 0, 1. Okay, that is by logic operation we are going to solve it. Okay. Then we have bitwise NOT. So this is the representation of bitwise NOT operation on the operand. Okay. So which goes like bitwise NOT A is equals to, it means minus, not in the sense it is the negation. So we are getting minus 3. Okay. So binary number of 3 will be negation of 0 0 0 0 0 0 1 0, that is 6 times 0 and 1 0 equal to 1 1 1 1 1 0 1, that is 6 times 1 and 0 1. Okay. Then we have the other signs, which is like greater than. Okay, so it performs a bitwise right shift. Okay, if it is on the right shift, then we are going to represent it like that. Then now shifts the bits of the left operand right by the number bit specified as the right operand. Okay, now A right shift B equal to 0. Okay, now here we always got to remember that our bits are not going to shift. Okay, it is just like the last part is going to shift. Then the last part we have as the left shift, which performs bitwise left shift, shifts the bits of the left operand. So the left side will be shifted now. So left by the number of the bit specified as the right operand.